doing, or they're going to deal with the graph. So this just says certain airline has the following carry-on, I can speak, luggage requirements. The length must be 10 inches longer than the width. Okay, so I'm just going to kind of, if the length has to be 10 inches longer than the width, let's say the length, I'll call that L, and I'll call the width W, how would I write 10 inches longer than the width, like an expression? Yeah. Yeah, we're just, well, I'm going to set the width plus 10, so I'm just going to do like W plus 10. Okay. Then it says, let's see, the sum, so that's adding, right? The length, the width, and the height must be less than 40 inches. So the length plus the width plus the height. I'm just going to say, we're just going to set that, just set that equal to 40 inches, okay? Now, what I need then is we're going to find the maximum possible volume for this. So volume, length, width, height, right? Or area of the base times the height, if you want to remember that from geometry. Now, the problem is I've got to create an equation that only has just the volume and one other variable, otherwise we won't be able to do this. So what I would tell you real quick, let's sub this in for the length. All right, so the length has to be 10 more than the width, so I'm just going to substitute that in there. Let me grab a different color. All right, so I'm going to put W plus 10 for the length, plus the width, plus the height, and it says we need to be, let's just say it must be 40. I shouldn't have that less than in there. Let's just say that must be 40 inches. Okay, now I'm going to simplify this just a teensy bit. So this would be 2W plus 10 plus the height has to be 40. Okay, if I'm going to try to make this volume formula something that only has just volume and one other variable, let me go through here. I could do volume. The length is the width plus 10, right? The width, that's the same variable. I'm just going to keep that W. Okay, how would you use what we have over here to maybe rewrite the height? Like, what would you do so I could write the height so it had, basically I'm looking for, those two expressions have the variable W, so it would be nice if we could get the height in terms of W. So how would you do that with this equation that we wrote over here? If I want the height in terms of W, what do you do? Add it to what? Yeah, exactly. You're just going to get H by itself here. That's exactly right. All you're going to do, I'm actually going to subtract it because they're both positive, but we're just going to move those two guys to the other side, minus 2W minus 10. I'm trying to get the height in terms of the width, so then we only have one variable on the right side of our volume equation. So I'm just going to write negative 2W, nothing to combine that with. 40 minus 10 would be 30. All right, so then I also have the height in terms of the width. So I'm just going to come back over here, and so my height, instead of writing H, I'm going to write negative 2W plus 30. Okay, now all we have to do, I'm going to type this into Desmos real quick. So the one thing that might be a little bit tricky is we're going to have to, I'll just redo this page real quick here so it's a normal graph. We're just going to have to write it in terms of X and Y. So let's pretend, I'm going to move this so you guys can see the formula here real quick. Let's pretend, and you can use the parentheses. You don't have to multiply this out or anything. What I'm going to do is I'm going to type into Desmos Y equals, just use the parentheses and you can put them in any order. I'm just going to replace the W with an X, and we're just going to remember that that's representing the width. So I'm just going to write Y equals, you don't have to multiply it out, just use the parentheses right there. The computer will take care of it for you. X is the width, negative 2X plus 30. And I'll move that in a second. I just wanted you guys to be able to see the lovely equation. So I don't know a way to get Desmos to recognize different variables other than X and Y. So I just typed it in, parentheses and all, you don't have to multiply it out. And I'm just going to kind of scrunch my graph here a little bit if I can. And it is really misbehaving this morning. What in the world? There we go. Okay, so I'm just like, I just scrunched the y-axis just like with my fingers. You saw it took me a couple seconds to get there. And we want to know the maximum possible volume. Where do you think I could figure out, like what point would I look for to find the maximum possible volume there? What do you think? Like what point would I be looking at? Here, I'll tell you what, I'm gonna just click on some points. So we got my zeros here, right? So got my zeros and I got my little points where the graph turns from increasing to decreasing. So I'll just kind of click on those. Which one of those points do you think I'm trying to look at if I want to maximize my volume here? What do you think? Exactly. You want to look at your relative maximum right there, right? Okay, so in this situation, x would represent the width, right? So we don't want to look at this point over here because that's negative. We don't want to have a negative width. So what you want there is your relative maximum. So that's going to be this lovely point right here. Now, which coordinate do I want? X or Y? X. Okay, so X is going to be right here. I'm going to write, what is that? 8.931. So not the greatest number in the world. What is Y going to represent there? What would the 2052.205, what would that represent for that situation? X, this is the width, right? What would the Y value represent for that? Yeah, the Y value is the actual volume. So the maximum volume there is just the Y coordinate of that point, that 2052 point, what is that, 205. That would be, and this would be inches cubed. So that would be my actual volume. So the maximum possible volume for the carry-on, that would be the Y coordinate of the point. The width that we would use would be the X coordinate of the point. If it asked you for the dimensions, like it asked you to find the height and the length, which it doesn't for this particular question, but if it did, we could just plug that back into those expressions that we had for the length. We would plug the X value in for the length and the height to find those dimensions if it asked you for it. Is anybody having a question? Okay, we're just going to try a similar problem right underneath here. Okay, this guy says, designed for digital camera, maximizes the volume while keeping the sum of the dimensions at 6 inches. So super similar here. The length must be 1.5 times the height. What should the dimensions be? Okay, so this is going to be another volume question. So length, width, height. This camera is going to be rectangular prism shape is the intention. I probably should have typed that in the question, but it says maximum volume. The sum of the dimensions is 6. So length plus width plus the height has to add up to 6. And it says the length must be 1.5 times the height. So how would I write the length? I'm going to write length equals, how would you write 1.5 times the height? Like what would that look like? What do you think? Exactly. Okay. Now this one is slightly different than the question we just did because the last one we were really working with information in terms of the width. So right now what I can do, I can substitute an expression for the length, but it's in terms of the height. So when we do this question, I'm going to try to get each of the dimensions in terms of the height, which I wrote an H for that. So very similar to what we just did, I'm going to plug this in for the length up here. So it'd be 1.5 times the height plus the width plus another height is going to add up to 6. Those are the dimensions there. All right, if I combine my like terms, how many H's would you have? Like what would you put in front of the H on the left side of that equation? So I have 1.5 plus another one. So what would you write in front of it? Yes, thank you. It's just a little one, so it's like, you don't have to change it to a fraction or anything, just 2.5 times the height plus the width would have to equal 6. Now, super easy, I'm just going to get the width by itself. I'm trying to write it in terms of the height. So to do that, I'm going to subtract 2.5 times the height. So it'd just be like 6 minus 2.5h. And again, when you guys put this, I'm just going to leave it in the format, just like a factored form kind of a thing. So for the volume, and for the length, I'm just going to put 1.5 times the height. And for the width, I'm going to put that 6 minus 2.5 times the height. And then in for the height, I would actually put just h for the height. So everything's in terms of the height there. That way I only have two variables and we can relate that on the graph. Now, I'm going to do the same thing. You can type it in. You don't have to multiply it out or anything like that. You can just type it right in with the parentheses like that. But we're just going to substitute x for the height and y for the volume. So I'm just going to pull this over again. And we're going to maximize this lovely little camera here. Sorry, I'm trying to get that on the screen so you guys can see it at the same time. So I'm just going to change this up. So 1.5, and then just put an x. I don't know, Desmos doesn't like other variables for some reason. So just everywhere I have an h, just replace it with an x, and I'm going to replace the volume with y. And then this question does say, what should each of the dimensions be? So, again, you might have to I just did that exactly wrongly from what I wanted to do. So I'm going to kind of try and pull this graph so I can look at it a little bit better. It's just going to take me a second here. Okay, you want to maximize. All right, so I'm just kind of stretching this around. And just mess around with it with your fingers. But if you do come over here and you click, again, you're looking to maximize, so you want that relative maximum. Okay, now, I want the x-coordinate of that point is going to give me the height. So for this question, my height is the 1.6. That would be in inches. The volume is going to be the y-coordinate of that point, which is the 7.68. Now, they don't specifically ask for that in the question. They ask what the dimensions should be. So then, if you need the other dimensions, grab my calculator, I'm just going to plug in 1.6 to those other expressions. So the length was supposed to be 1.5 times that, so just do 1.5 times 1.6, so it'd be 2.4 inches. And the width is 6 minus 2.5 times that 1.6, which is going to be 2. It's not terrible to do. It's a little tricky to set up, but once you got it, you're just going to use Desmos to help you answer the question. Does anybody have a question? Bless you. Okay, now both of those questions had to do with maximizing something. These other two questions that we're going to do here real quick are still going to use a graph, but they're not going to maximize anything. So we're not going to be looking at a relative maximum or minimum here. Okay, this says the height of a pod's moving container is 4 feet less than the width, and the length is 9 feet longer than the width. The volume of the container is given to us here. It doesn't ask us to maximize this, so this is a little bit different. So the volume is going to be 336. So again, I'm just going to write down volume is equal to length times width times height. I'm going to show you two ways to do this question, and you just pick whichever one you like better. Okay, so I'm just going to write a general formula for the volume here. So it says the height of the moving container, so I'm going to write H, is 4 feet less than the width. So I'm going to do width minus 4. And then it says the length is 9 feet longer than the width. So 9 feet longer would just be adding 9. And this will be nice for us because all our variables are going to be in terms of W as we go through this. So I'm just going to go ahead and we don't have to solve anything or anything from this point. I'm just going to plug in my length is my width plus 9, and my width is just the width, and then the height was the width minus 4. And again, you don't have to FOIL that out or anything like that. You just can put it right into Desmos, right in that format. And then it wants the dimensions of the container. Okay, now here's the difference. Go ahead. Yes, okay, that's what I was going to tell you guys. Okay, there's two ways you can do this. So, you can set this up like this. 336, W plus 9, W minus 4. Okay, now if you do that, Desmos is not going to graph that because you don't have another variable. So what you would have to do, and this is just one option, is I would basically subtract the 336 and you would graph, and you could just leave those parentheses if you want to, that W minus 4, and then you'd have like minus whatever the volume was, which was the 336. If you want to do it like this, then you find the zeros on the graph to represent the width. The other way you can do this, which this is what I usually do because it's just a little bit faster for me, I will graph like a system. So I'll graph just y equals 336, which will be a horizontal line to represent the volume. And then the other equation I would graph would be that width plus 9, width minus 4. Those don't have to come in a particular order. If you do a little system like this, what you're looking for is the intersection. Bless you. And that'll give you the width. So whatever way, I'll show you both here real quick on Desmos. So whichever way you like better, that's what I want you to do. But either one of those methods will work. The reason I usually do the system is because I always forget to subtract the 336, but if you do it that way, I'll show you, just use an X instead of a W. Okay, so if I graph it like that, and then I'd have to do minus the 336. And then again, I'm going to probably have to stretch this a little bit so I can actually see it. Whoops, sorry. And you're going to go in that scenario for the 0. So that would just be 7. And that's representing the width. So let me just real quick, I'm going to come over here and write that for my width before I forget it. If you would rather try a system, that's totally up to you. Like I said, that's how I usually do it. So in that case, I would just do my volume formula, and then I would just do y equals 336. And I'm going to have to move this graph a little bit because 336 is going to be a little bit higher than what I had on the screen. And then you'd find the intersection point. And then again, the x-coordinate there's 7, so it's the same answer. It's just a little different way to do it. And then that, in that case, that shows you that the volume's the 336. So whatever is easier or faster for you, that's what I want you to do. And then I can come over and move that out of the way. All right, so if my width is 7, to get my height, I'm just going to subtract 4 from that. So that'd be 3. What are the dimensions here? This is in feet. And my length is the width plus 9, so this would be 16. And if we multiplied those 3 numbers together, we should get that 336 if we wanted to check for our volume. So 2 different ways to do that. If you want to set it equal to the actual volume, you have to subtract that from both sides to set it and find the zeros. If you want to do a quick system, find the intersection. That's another fast way to do it. That's where you're showing that the volume formula will be equal to 336. Okay, you guys see if you can set up this one on the back. And then go through, and I'm just gonna leave my screen up here frozen for a second. And you guys can see if you could set this up real quick. I honestly don't remember off the top of my head if this has nice answers or not. Probably not. The volume's like 5.9. So see if you could set up an equation for this. It's going to be more similar to the question we just did. And you can go ahead, any of these questions, if it doesn't say otherwise, go ahead and assume that it's a rectangular prism shape. When you feel like you've got a good equation, just go ahead and grab your Desmos and just switch up and just make sure you use an X and Y when you do it. And you might have to stretch the graph around a little bit with your fingers. And the answer for this one is not a nice number when you get it. There's a couple problems on the homework that you can try on your own if you're feeling comfortable with this. And then I do have a quick set of questions on notebook math. If you need a link for that, feel free to grab that out of the calendar in Canvas. These are all looking really good. You guys are looking really good with this. I'm going to move this to the side here, that 1.837. The width should have been 1.837. I saw that on almost everybody's paper that I was just looking at. And then if you want to add 2 to that to get your length, that would be 3.837. And then your height, you're going to subtract 1 from that. So that would be 0.837. And these guys are all in cubic feet. So the dimensions would just be in feet.